Good morning, my name is Sophie Stumacher, and I'm here today to present to you my project, Peekaboo, Determining the Latency to Laughter in the Case of 3 Different Jokes within infants aged 6 to 18 months. Watching a tiny baby giggle is one of the most highly anticipated and cherished moments of parenthood. Laughter is universally experienced, it emerges at around 3 to 4 months, and it is a vital early communicative tool. Laughter is exceptionally important to study and learn more about because it increases health, it leads to higher self-esteem, it's linked to a greater enjoyment of positive experiences, and it helps reduce the possibility of developmental issues. One of the most fundamental aspects of infancy is the bond between an infant and their caregivers. This bond or attachment is essential for development, as it is crucial that an infant feel that they can rely on someone. Laughter is the easiest way to begin, strengthen, and nurture said relationship, and infancy is a critical time to develop of secure attachment. However, if the parent or guardian does not make an effort to bond, this may lead to an insecure attachment. Insecure attachment can lead to many long-term poor mental health outcomes, such as depression. This secure attachment has been related to positive outcomes including emotional regulation, prosocial behavior, and achievement. And evidently, it is of extreme importance that the parent or guardian make the effort to grow and nurture a relationship in order to avoid possible future mental health outcomes. Thus far, there has been a lot of research conducted prior to the study, including exploring topics such as age, sources of laughter, and temperament. Some major findings from studies that investigate age include the fact that laughter begins at 3 to 4 months, and speaking usually begins at the end of the first year. In addition, many of the studies conducted in the field of infant laughter utilize a wide range of triggers for laughter. For example, visual cues or auditory cues from either parents or video clips, and more. And lastly, temperament has been thoroughly explored as researchers were curious to determine if a certain temperament yielded a greater affinity for laughter. With all this knowledge in the field, a latency period has yet to be properly investigated. A latency period can be described as the elapsed time between the start of the joke and the first instance of a response of laughter. Thus far, to my knowledge, it has only been investigated once in Murrell et al. 2015, but that was not even the main focus of that particular study. Knowing this, there is a gap in the literature about how the latency period is impacted based on age and joke type. My objectives include determining the frequency of trials that elicit laughter for each joke type, determining which joke type elicits the longest latency in the younger cohort, as well as determining which type elicits the longest latency in the older cohort, and lastly, comparing the latency time for both the younger and older cohorts for each joke type. My working hypotheses include as the age of the participant increases, there will be no relationship to latency time, and Peekaboo will present with a significantly lower latency period than the other joke types. My role in the study began with familiarizing myself with existing literature by reading 28 journal articles. I then independently secured a mentor who happens to be the world's leading researcher on infant laughter. From there, I spent time creating 3 different possible studies that I pitched to my mentor for us to discuss. After the pandemic hit, I was unable to complete the original research due to travel restrictions. My mentor and I communicated weekly through Skype, discussing the possibility of me exploring previous data collected by his research group. From there, I learned the coding programs I would use to carry out the project, including DataView and Jamovi, and I then carried out the project over the summer under the guidance of my mentor. For the age ranges, we had 2 cohorts. The first was the younger cohort ranging from 6 to 12 months, and the older cohort included ages 12 to 18 months. There were 3 joke types. The first was the absurd joke, also known as not a hat, and this ran as such. A parent would place a bottle on their head, exclaim, "Look at my new hat," and in hopes of laughter. The second was the conceptual joke, or peekaboo. This ran like a normal game of peekaboo. The parent would cover their face, open their hands, smile, and say peekaboo. Lastly, the uncategorized joke, or tearing paper, would run as such. A second coder was utilized. I functioned as the first. The main reason for the inclusion of the second coder was to ensure both coders agreed on whether or not a reaction should count as laughter, as well as to certify the values obtained by the first coder were not inaccurate. Latency time was measured in a unique way. It was measured only if there was a distinctive pattern of vocalization that is instantly recognizable as laughter. This is a snippet of DataView. First, the video is checked twice, then it was uploaded to DataView. The laughter time was recorded by using onset and offset values. Then the difference of the two values is calculated and eventually entered into the Excel spreadsheet. This is a small section of the Excel spreadsheet. This data comes from a study that was performed previously by my mentor and his colleagues, which you can feel free to ask me and further explain during the question and answer portion of the presentation. The red bars indicate areas I did not revisit during my study. To the left was more participant information with age, child ID, and more. For each joke, there were 3 trials. For the 3 trials, there were 2 columns, one for the parent to describe whether or not they believed there was laughter present or not, and the other to input the latency time. If no laughter was present, NL was recorded. Here are my results for parental opinion. It's important to note upon analyzing the data, we found discrepancies between what the infant's parents and the experimenters believed a laugh should be considered. We did not analyze whether there was a significant difference between the counts for parents and coder. For the conceptual joke, there was the parents believed their child had laughed 1.5 more times for the younger cohort, as well as for the older cohort, it was 2.85 times for this joke. For the absurd joke, for the younger cohort, the infant's parents believed their child has laughed 1.55 more times than the experimenter, and for the older cohort, it was 1.5 times. And lastly, for the uncategorized joke for the younger cohort, it was 2.21 times, and for the older, it was 1.4 times. This inconsistent appraisal of laughter was not expected as it's rarely reported in previous studies utilizing parents assessing laughter. The most logical reason for what we report are parents may be more likely to show bias, be more optimistic about their child's laughter, and additionally, they're more experienced in the nuances of their child's expressions and verbalizations. However, this bias is a very interesting notion as the parents and guardians were directed to be as impartial as possible. Next are the laughter counts by age. The number of trials that were filled with the sound of laughter decreased with age, which is the opposite of what we predicted in the first working hypothesis, as shown in the pink boxes highlighted. As the age increased, it was expected that there would be more instances of laughter, as infants would be older and have more experiences leading to laughter. However, that was not what was observed. For laughter counts by age, we found that the peekaboo was the joke that had the greatest number of trials of laughter present, with the experimenter reporting 51 laughs. This was predicted as peekaboo is a joke that is used over many cultures, for many ages, and has been dubbed the universal way to make a baby laugh. Additionally, chi-square analysis found that there was no statistical significance when comparing infants' observed laughs versus expected laughs, as shown by the p-value being less than 0.05. Next, for the absurd joke, this joke was the joke that had the second most number of trials resulting in laughter. For this joke, the experimenter recorded 34 instances of laughter, as well as a chi-square analysis showed no statistical significance. And lastly, the uncategorized joke yielded the smallest number of trials that resulted in laughter, a mere 19 trials reported by the experimenter. And as a result of the minimal trials of laughter, with laughter present, this led the average of latency times to be scattered compared to the other 2 jokes, especially in the older cohort range. In addition, I also analyzed latency time per age. When comparing the age groups to latency time, the t-test revealed statistical insignificance. Once again, there were longer latency times recorded for the older age group, which is the opposite of what was expected. Next, I also looked at latency time per joke type. For the conceptual joke, this joke yielded a 1.8 average second latency time. The t-test was insignificant, however, the 2-key test was, as shown in the pink box highlighted in table 1B. This meant that there was the greatest number of trials eliciting laughter, as well as this joke was the shortest average latency time. Next, for the absurd joke, it yielded a 2.66 second average latency time, which was the longest out of the 3 and had the most similar reaction time, as shown in the pink box highlighted. The average latency time was longer, most likely because this joke may be less familiar than the conceptual joke. However, it was still produced in a positive, humorous effect. This can be assumed as the joke breaks social conventions, including what a hat actually is and the correct use of a cup. In addition, the absurd joke is namely the joke with the most similar reaction type, as shown in figure 2 in the pink box highlighted. The average latency time for the uncategorized joke was 2.25 seconds. And interestingly, the range for the latency time lasted as long as a second and a half. As mentioned previously, this joke may not have been performed in a humorous context, and for the future, an investigation should further explore this joke in a humorous context, possibly dedicating an entire study to uncovering information about why infants find the ripping of paper so interesting and funny. In addition, this joke should be explored developmentally to determine whether or not this joke becomes funnier as age increases. Overall, I also looked at latency time per joke per age. Interestingly, statistical significance were found statistical differences, were found to all result in significance, and because of this, the post-hoc tests were run in order to confirm where the differences occurred between groups, which were earlier in the presentation, Table 1A and 1B. After analyzing the data, we are able to reject the first working hypothesis, stating as the age of the participant increases, latency time will also increase. We found that infants aged 12 to 18 months were shown to have a longer latency time than those 6 to 12 months, although that was not found to be significant. Additionally, the data accepts the second working hypothesis, stating the conceptual joke will present with the least amount of latency time. We found that the conceptual joke had a significantly shorter latency time than the other joke types. Although not all values resulted in statistical significance, there is still a great deal to be gleaned from the gathered data. Investigating laughter and latency periods plays an important role in understanding child development and attachment. This is important. We need to harness our knowledge of this vital human instinct to build better relationships, which lead to a happier, more joyful childhood. I would like to thank my parents, my mentor, and teacher for all their continued support throughout my time in the science research program. Here are my references. Thank you, and I will now take any questions.